All right, now we have done definition solutions, verifying solutions, and graphing solutions. That's all done. The next thing we'll do for part 3 are intercepts and horizontal and vertical lines. Intercepts. First thing we'll do is just look at the graph and get the intercepts. Definition: an x-intercept is where the graph crosses the x-axis. A y-intercept is where the graph crosses the y-axis. So one thing to note, this is an important note, and I will continue to stress it for the next several weeks. An intercept is an ordered pair. It's not just a number, it's an ordered pair, and I'll show you why it's important to remember that. Okay, if we look at this graph right here, it might be slightly hard to see, but if you kind of zoom in, look at where the graph crosses the x-axis, and look at where the graph crosses the y-axis. So for my x-intercept, where does the graph cross the x-axis? Well, it looks like it crosses right about 2. Now, I don't want to write down 2. An intercept is an ordered pair. How do I write that point? Is it 2, 0 or 0, 2? Remember which one. It's easy to get confused. Well, 2 is the left, right, so it's 2, 0. Now, if we look at the y-axis, it looks like it crosses about at -4. So, how do I write that as an ordered pair? It's important to write an intercept as an ordered pair. Well, I go over 0 and then down 4, so it would be the point 0, -4. Okay, for this graph, pause the video and write them down on your own, and then restart. Okay, now that you've got those, it looks like for the x-intercept, looks like it crosses it at 3. I need to write that as an ordered pair, so it's 3, 0. 3 for x, 0 for y. For the y-intercept, it looks like it crosses about 9. So that's the point 0, 9. Just remember which place gets the 0 and which place gets the number. Okay, now that you know how to find the intercepts if you're given the graph, I want you to find the intercepts if you're given the equation. The definition is exactly the same. An x-intercept is where the graph crosses the x-axis. A y-intercept is where the graph crosses the y-axis. Now think about what that really means and what we noticed on the graph. We know that the y-intercept, that's where x is 0. So we're going to let x equal 0 and solve for y. Okay, to find the x-intercept, we need to do just the opposite. We're going to let y equal 0 and solve for x. So if we have this equation right here, I want to find the intercepts. Now to this date, this is what I write down. To find the x-intercept, I still write down x int and y equals 0. That just reminds me exactly what I'm doing, and it helps organize my work. So to find the x-intercept, I'm going to put 0 in for y, use parentheses to plug in that number. -40 times 0, that makes my life easy. Remember, plugging in zeros are always easy. So we have 20x equals 200, divide both sides by 20, and x equals 10. Am I done? No, an intercept is an ordered pair. How do I write that as an ordered pair? Okay, 10 for x, 0 for y. And notice I had x equals 10. That tells me 10 goes in the x spot. And I plugged in y equals 0. That tells me 0 goes in the y spot. Okay, for the y-intercept, I'm going to let x equal 0. So my little heading kind of gives me directions. So I put in 0 for the x. Is it time to divide yet? Not yet. I need to get the y term by itself. I could have subtracted 200 from both sides. That would have worked just as well. Divide both sides by 40, or -40 if you'd done it the other direction. I get y equals 5. Now how do I write that as an ordered pair? Okay, I put in 0 for x, that goes in the x spot. I put in 5 for y, that goes in the y spot. So remember that we have ordered pairs, not just numbers. I'll show you where that could lead you astray in just a second. So if we're going to graph those, well, the point 10, 0 is right there, and the point 05 is right there. So all of a sudden, I've graphed all in one step. When we are graphing, what I'm doing is essentially filling up a little toolbox. Your XY chart or your table of values, that's one tool. That's this multi-purpose tool that works for everything. Your intercepts, that's a little more specialized of a tool. It actually does the same thing. It still graphs the line. It just does it in a different way. Okay, horizontal and vertical lines. Let's say that we have this linear equation in 2 variables, but one of those numbers happens to be 0, so all of a sudden I'm back down to 1 variable again, like y equals 4. Now back in chapter 1 and chapter 2, this would have just been the answer to one of my problems. All of a sudden now in chapter 3, This is a whole different thing. Since I'm now in the land of two variables, this actually means something. What ordered pairs are solutions to this? Well, I know y has to be 4, but does it matter what x is? There's nowhere to even plug in for x. So I could plug in 0 for x, that seems obvious. But I could plug in 4 for x. I could plug in 7 for x. There's nowhere to plug x in. As long as I'm plugging 4 in for y, I'm fine. I could have -2 for x. I could have -10 for x. So if I plotted plot all those points on this graph, and connect the dots, I'm going to have this line right here at y equals 4. So if you have y equals a number, it's a horizontal line. So a horizontal line has the form y equals a number. That says x can be anything it wants. X can run back and forth. Remember, x is left and right. X can run to the left, x can run to the right, but y is fixed. A vertical line, what is that going to look like? Well, that's going to say that I can go up as much as I want and down as much as I want, but the x value is fixed. So y can be anything, right? Y can run up, y can run down, but x is fixed right at that number. So let's look at some examples. If I have y equals 2, that says x can run to the left, x can run to the right, x goes left and right, but y is fixed at 2. Now how about this one? I don't have y equals a number. But I do know that if I solve for y, I'll just add 2 to both sides, y equals 0. Now where is that? It's a horizontal line. X can run back and forth. It's just the x-axis. Y equals 0 is the x-axis. Sometimes that throws people off, but think about it. X can go up, x can go down. X can be any value along there, but y is fixed at 0. Okay, again, if I solve for y, I get y equals -4. X can run to the left, x can run to the right, but y is fixed at -4. Now for x equals 7, there's no y. I can plug in any value of y that I want. Y can go up, y can go down, but my x value has to be 7. So think of y as running up and down that line. Y has total freedom because he's not in the equation. X is locked in at 7 now. Okay, solve for x first. I get x equals -2. It's got to be a vertical line. Y has freedom to run up and down. X is fixed at -2. And x equals 0, where is that? Exactly right. It's right along the y-axis. Those are your horizontal and vertical lines. That is the end of section 3.2 in your book, but we still have more stuff to do in this lecture. So the stuff that's coming up, this is in 3.3 of your book, and it will be in the next part of the video, and that will be slope. It's the next tool that we have in our graphing toolbox.